Have you ever been watching a movie and thought, there is no way that's possible? Yeah, so have I. This is a scene from 2015 blockbuster Furious 7. The Fast and the Furious films are famous for their death-defying stunts, and this is probably known as the craziest of them all. Is there any way this jump could actually happen in real life? Well, using some simple dynamics equations, we can determine just how crazy this jump is. So let's take a closer look.
Time to unleash the beast.
The car performing this stunt is the Lykan Hypersport. Only 7 of these cars were ever made, and these things retail for a whopping $3.4 million. You'd have to be Vin Diesel to afford this car. Because of the limited supply, they couldn't exactly drop one of these things out of a building. To get around this, the team behind the stunt cars in the films made a copy, using cheaper materials, like swapping fiberglass in for carbon fiber.
So the Lykan Hypersport, this car was a real tough one for me. When I read the script, I'm thinking, my God, this is Dubai. These guys, drive a Lamborghini Aventador, to Starbucks in the morning. What am I going to feature? What can I put in this guy's, penthouse? Somebody on the crew did, hey, check this out. I went, oh my God, I read about the car. I go, it doesn't get any better than this. It's the first UAE-produced supercar, and they're only going to build 7. It had the hefty price tag of, I think, $3.7 million, but it was really disappointing that there was only 7 produced and only 7 guys were going to have it. Once I met the guys at, from Lykan, we had a meeting, discussed the car, discussed what they could do for us. We really had no way to create these cars because we had no molds, we had no CAD data, so they actually built us the bodies, gave us some rollers on, basically on a Porsche Boxster chassis. Everything was actual production quality. Just under the skin, it was, it wasn't a 200-mile-an-hour car, but luckily we were only driving in the interior of a building, so I think 35 was as fast as we ever had to go.
Alright, so now that we know what kind of car we're dealing with, let's look at the real fun stuff, the math. The first step in figuring out if this jump is possible is to break down the elements in the scene itself. It appears the car is falling about 2 stories, which is around 20 feet. We also know the distance between these towers is roughly 150 feet. With these numbers, we can use this equation to determine the amount of time this jump would actually take. We can set our initial height equal to 0, because our final height will be 6 meters or 20 feet. For acceleration, we can use 32.2 feet per second. This is the acceleration of gravity. Plugging in all these numbers, we can find time. The next step is using this equation, distance equals speed times time, to determine our velocity. We know that our distance between the towers is 150 feet, so we'll use that as our distance. And we just calculated our time in the previous equation, 1.11 seconds. You take 150 feet over 1.11 seconds, and that'll give you your velocity, 93.70 miles per hour. But hold on. In the behind the scenes of the film, we learned that since they were actually driving this thing inside a skyscraper, they never got the car over 35 miles per hour. Well, we can calculate where exactly the car would have ended up if they had attempted this jump at that speed as well. Using the same equation, but solving for time, we see that distance over speed equals time. We take our 150 feet gap between the buildings over our 35 mile per hour actual speed, and we get a 3.01 second time frame for the jump. Now we plug that time into this equation, and we get that 1/2 times 32.2 feet per second squared, the acceleration of gravity, times 3.01 seconds, our time, squared, equals 145.63 feet for our drop. That equates to about 15 stories. With that much time to free fall, well... Next, I wanted to know whether or not this car would have enough distance to come to a full stop after attempting this jump. This equation is used to determine how much distance a vehicle needs to come to a complete stop. We take our velocity squared over 2 times the coefficient of friction times the acceleration of gravity. Using our velocity of 135 feet per second squared, over 2, times 1, we'll use this for our coefficient of friction, times 32.2 feet per second squared, we find that our distance required to come to a complete stop is 287.04 feet. Given the fact that the tower is only about 250 feet wide, just like in the film, the car would fly out of the other side of the building, which is why the two heroes bail at the last second. But just how much time would they actually have to make that call? Well, using this equation, we can determine our acceleration. Velocity squared over 2 times x distance equals acceleration. So, our 135 feet per second squared velocity squared over 2 times 246 feet, the size of the building, equals acceleration. That brings our acceleration to 37.57 feet per second squared. Now, you take velocity over acceleration, and that'll get you your time. So, 135.96 feet per second over 37.57 feet per second squared gives us a time of 3.6 seconds. This is enough time to make the decision, but probably not quite enough time to actually jump out of the car and pose it up on the edge of the building. It's also important to note that, at the speed they were traveling, jumping out wouldn't have done much, as they'd be traveling with the same momentum as the car, and would likely fly over the side as well. So, is this stunt possible? Well, yeah, it is, but you might lose a few drivers making it happen. In my research for this video, I actually found an article where physics professor Lee Loveridge was asked by an interviewer if the stunt was even possible. He replied, "It's probably the most realistic stunt in the whole series." In the end, though, I think we should all leave the skyscraper jumping to Vin Diesel and Paul Walker. Thanks for watching. I'd like to give a shout out to my professor, Damon Sisk, for challenging my dynamics class to this project. It's been a lot of fun, and I hope to make more like it in the future.